Timber Talks is brought to you by Wood Solutions. Stay up to date with the latest in timber, the building material that is strong, safe and sustainable. Here is your host, Adam Jones.
Sidewalk Labs are owned by Alphabet, the same organisation that owns a familiar company called Google. So they combine forward-thinking urban design and cutting-edge technology to radically improve urban life around the world. Now they're planning to build a city out of timber as part of their Quayside development in Toronto to get the carbon sequestration benefits, rent premium, and also the fast build times that's possible with timber. Today we're chatting with Karim Khalifa, who's the Director of Building Innovations, and we're going to be speaking about the timber buildings they're looking at, which includes a 35-storey proposed timber tower, also how Alphabet engineers are assisting them in the urban planning process, and also some of their innovative fire design approaches. Now, it's a real privilege to get to sit down with Karim. I'm sure you're going to enjoy this podcast interview, and without any further ado, here is the podcast with Karim Khalifa.
Senior executives of Alphabet really thought they were interested in applying what would happen to a city if it applied technology, digital technologies from the beginning. Would it be designed differently, and how would it approach the infrastructure and the vertical buildings, and what could it do for the residents and tenants in office buildings? So they approached Dan Doctoroff, who had been deputy mayor of New York, and said, how could we do this as one? So Sidewalk Labs was formed. It really included three groups that typically are not in one company. And you have really people who would be in a government office. You have what a developer would also have as in their office. And then finally it has the digital expertise in the engineering group from Google. And so when you put these three together, you think you could get one integrated design, and that includes how people, city planning and how people want to live in a city and how they use the services of a city, as well as how we construct the buildings and the infrastructure, as well as how we use that digital platform.
Yeah. Historically, construction companies haven't had the ability to invest a lot in research and development with such tight margins. Do you think it opens up new opportunities being an Alphabet company and known by Google to be able to explore all the new things and find the next step and the next leap in construction?
Yeah, I think it is a big opportunity. So we don't really want to be a construction company. We really want to enable the construction industry to do new things. So we are a startup. So with it comes the good and the bad. It means we have a long-term view in order to launch this company and do something big. We also have patience in the Alphabet company to really want to change the industry, and they understand it doesn't happen very quickly. So that's been a huge advantage, which I think a lot of companies really don't have.
Mm. And you mentioned how there's a different kind of skill set, having access to engineers from Google, and you've got another whole range of cross-disciplinary skills on your team. What does this enable you to do, and what unique challenges are you able to solve with this and mix of skills?
Yeah, so you can always ask a question, and there's always somebody that has some expertise in either how a city would embrace that thought, how the developer would need to make it happen, or how the digital world could really enable something new to transpire. And so you could ask any question, like where should we put a school? And we can get a response really from all three. So how do you make that school really connect to the children that are going to attend that school? From a development point of view, how do you make the school really dynamic so it can service new types of classes and learning in future environments? And then, of course, the digital guys saying, we can enable all this to happen and turn it on so these children would have this type of environment where they'd be learning really in the next century. Yeah, so our digital team really put together what we call the generative design package. And this was, could you take variables and that we would be interested in city planning, and take variables of architecture and construction and roads and infrastructure, and put them into a model, and then actually have the end user look at how those different variables can be dialed up and dialed down, and then really start to think about what are the priorities for the type of neighborhood that they want to live in. So a simple example is if you have a certain percentage of parks in a neighborhood, do you centralize it and make it one grand park? Or do you put a piece of it on each parcel so everybody has an adjacent smaller park? And so those are trade-offs that only a neighborhood resident can really give you. It's how they want to live. But what they start to do is they start to see, I can't have it all. I can't have that big park and the local park. I only have so much land because that's probably constrained by the value of the land and what needs to happen as a financial market and because of the density needs in a city, especially like we're looking at in Toronto. So they immediately start to see some of the trade-offs and really starts the discussion of what is our priority? Is it to have a big park or smaller parks? And then you can take that on to, do I want the sunlight to hit certain areas of the neighborhood in different times of year? And so how does the shading work? How do we think about the wind going down the streets and comfort for us in the winter, especially on Lake Ontario where we've been modeling? So they get to see all the trade-offs of building shape to sunlight to wind, and start to really learn that this isn't just, you can't ask just for the moon. Everything's a trade-off like we know in life.
Absolutely. Yeah, about this Quayside project, can you tell us what this project involves and what the city might end up looking like and your involvement in this process?
Yeah, so a lot of us have a slice of this. So I'm the director of buildings. So it was really what type of buildings do we want in this neighborhood? But of course, this all came from Waterfront Toronto and the tri-governments of Canada, the federal, the provincial, and the city, thinking they wanted to expand this land, which is basically a brownfield site. There was industry there, the land is underutilized, and they wanted to, first of all, clean up the soils there that have been left by old industry, and then really produce a new section of the city that is actually walking distance to the center of Toronto city center. So with that, we started to think about, they asked, we wanted an innovation district that will propel Toronto further on its in its tech really prowess in North America today. And they also had quite a few immigrants, and a lot of the city has been growing, and they really needed to also address affordable housing, which has become quite scarce. So with those basic two, and we can go on for a lot of their parameters, they put out a request for proposal for entities to come forward and say what they think they could do in this neighborhood if they were given the chance. And we responded, Sidewalk Labs responded with their ideas. They won the proposal. And the first task was to really create a master plan that would describe more fully with a lot more detail of what could be. And that's what's under evaluation today. And I'm hedging a little bit your question about what is it going to be inside of there, because I really wanted to give the backdrop that this is a city-based project. And so our first step was really to ask the city, the residents, what do you want from this new neighborhood? And they've responded that they would like something that addresses the water more, and make it more interactive at that scale. I think we've also thought that some of the very tall buildings that Toronto has at 50 stories or more is probably not appropriate for that environment. So we tried to lower the buildings a little bit to create a little bit of a tighter community. And that was kind of our approach and some of the feedback we had heard from the residents. Yeah, so we originally proposed to do timber buildings and modular buildings, meaning off-site construction. We didn't know how far we could take it, I think, and with some study we realized we can now go to 35 stories with timber construction. But that took design and effort to realize what those limitations could really be. And it's actually, you can go with taller buildings, and we see those announced, but they also have to take care of how much space is utilized because the columns get quite big. So the available space on a floor plate gets reduced as those columns get bigger. And so that'll be the design challenge for everyone going forward. You can build taller buildings, they just aren't quite as efficient. But our idea was to build an all-timber neighborhood. And we thought it would be really a unique feature to be walking around with these very warm buildings on an entire city block scale. We were really fortunate that some of the parcels that are not included in the project zone just across the street, George Brown College is building a new timber library, about 9 stories tall. There's another couple of plots that will have commercial buildings and residential buildings built in timber also. So the whole neighborhood now, I think, will have just this unique experience, and it'll be the biggest one, I think, built in the world. And it'll be fascinating to see how the general public, and I'm sure lots of visitors, respond to that.
Yeah. And at the moment, you're building a factory. And can you tell us what this factory is and how it's unique and how you might be able to add value to panels and off-site construction in general?
Yeah, so we aren't quite building a factory yet. We are planning to build our factory, so we're waiting for Toronto's response to go forward. So our plans are to build a factory once we get an approval from Toronto. And that factory is really taking the outputs of the sawmills for cross-laminated timber panels and glulam beams would be taken into the factory, and we would convert them into assemblies. So if you can imagine a wall assembly with windows in it, all sealed up with steel brackets to mount that wall panel from the outside, those are the types of assemblies we would build inside the factory. So they would be very organized. Each one would have its own barcode. They would be loaded onto a truck. The crane would know exactly how to erect it. So one of the features would be to do a lot of work in the factory and be able to build these buildings very rapidly on site. So this would, first of all, get the housing up and available much earlier, but also save the development time to get these buildings completed, which helps the certainty of the project, which obviously goes to the bottom line for everybody involved.
Yeah, in your presentation yesterday, you mentioned of optimizing the supply chain. Where do you see where the most potential for the optimization might be of the whole supply chain?
So the optimization comes from really, the first one is that we do really good planning work and we understand exactly the materials we need and when we're going to need them. So once we can do that, we can really start talking to the supply chain and saying, this is our forecast for the next 10 years. And so this is really akin to what the auto industry does today. They know they need so much steel, they need so much wheel assemblies, motor assemblies, and so they're able to forecast to some of those sub-suppliers exactly what they'll need and when. Once you do that, you can start now working on refining what those suppliers are providing. They can prepare to provide the right item at the right time and at the quality that you're required to have. That's missing in on-site construction today, where people put out bids every time they win a project and say, I need, so much even timber or steel or whatever that is, and people corral up everything they can and then ship it off to the site. So they don't have this continuous motion machine where we continuously refine. And so this factory approach is going to really give the supply chain a lot of information earlier that we can negotiate with for both quality, timing, and cost.
Yeah, one of the comments a lot of people, building professionals, it seems it's the same in USA as it is in Australia, is that, that people believe the supply chain isn't ready. But as you mentioned, it might be just the information flow between the designers to the supply chain and how quickly they can act upon that information might be the actual issue. So it sounds like this is the thing you might be able to solve.
Yeah, I think this is, and the size of the project in Toronto at about over 3 million square feet really helps build up a pipeline. So it's really worth it for the suppliers to take it on, spend a little effort to up their game or up what the product offering could be for that building assembly. And that 3 million commitment really gets them to make an investment. Hopefully this isn't just the 3 million, right? That once we understand and refine our program, we start to get better and better at it, and our supply chain also gets better and better at it. The only thing I would add is the production of glulam and CLT in Canada today isn't sufficient to really address all the buildings that are emerging. So today we see a lot of imports from Scandinavia and the Alpine countries in order to meet the needs of North America, which in a lot of ways is kind of a shame because the raw product of trees is definitely available in Canada. So by forecasting a continuous demand from us to those CLT and glulam plants, we think we'll see new plants come online, or the existing plants will also increase their capacity. So this hopefully will create a new foundation for others to build timber buildings also in Canada and beyond in North America.
Yeah. When it comes to sustainability, what is your approach at Sidewalk Labs? Do you have any unique ways of increasing this portion of the projects that you're working on?
Yeah, so the baseline for us is we focused on Toronto Green Standard 3. And for many of those who wouldn't be familiar with that, it's really at a passive house level of performance for the building. So a very high performance building envelope and high performance electromechanical systems inside. So that was our actually starting point. After that, we looked at carbon sequestration of the timber, which a lot of people talk about, that these are really trees that are farmed or forests that are taking away some of the thinning so they can produce timber. So we're actually harnessing that carbon and putting it inside our carbon vault, which happens to be a building. But beyond that, we started looking at something that's called cradle to cradle. Many people may not be that familiar with it, but it's basically a certification program that really focuses on all the materials that get into a product should be coming from a natural state. And at the end, when they retire, they should be able to go back into another product or a natural state. And so we started to look at which materials would be retired from our buildings the most frequently. And so we focused on flooring and walls and cabinetry, right, which any resident or tenant may renovate, or the next occupant would change over. And if we got those to a level of cradle to cradle, we would really have a chance to reduce that renovation waste stream, at least make it a green waste stream. So that was really one of our big approaches. The other portion was to get a really great, efficient energy model working. And so working with all the infrastructure in the streets, we have created a thermal loop so we can exchange our heats between our residential and commercial buildings at different times of the day and really optimize that infrastructure. And then we put batteries in our buildings, so during peak power demand, we don't need peak power, which starts to turn on fossil fuel plants inside of Canada. And we can really meet all of our own peak power demands within the building by using our battery system. So we got out of peak power, we start to exchange thermal loads between different types of building uses, and we have this very high performance building envelope. And with all of that, we can really get to a carbon neutral or carbon positive neighborhood. And that was one of our main goals.
Yeah. One of the things you were talking about, again, in your keynote was about fire, which you take pretty seriously, because when we're talking about mass timber buildings, this is a challenge everywhere in the world. What is your approach to fire, and how can you help use some of the technology that you might be able to have access to and develop yourself to improve the fire design of buildings to be able to expose enough timber?
Yeah, so when everyone is worried about the fire and fuel contribution of mass timber. In reality, all the tests that we see across the world are showing that that's not really true. Nonetheless, we need to do our work to make it and minimize it as much as possible. So there's a few ways to do it. Obviously, the inherent value of mass timber is that you can encapsulate it with another layer of mass timber, and just like a smooth log put on the fire, it doesn't burn very well. It actually just chars and gets black. And as long as we don't get that heat to go into the core of that member, it doesn't ruin the structural integrity of the piece. And then you can chip off that blackened charred layer because it was sacrificial, and just add a new layer again, and the building will continue to perform. So that's the natural way of doing it, using timber itself. But we started to think is how could we actually cover the timber when we need to with another substance that was also green. And so drywall is the typical method, but we looked for something that was cradle to cradle, like I described before. So we actually found this ancient substance, I don't know if ancient's the right word, but 1,000-year-old substance from Japan that's called shikui. And we found that it actually had properties that probably could do this job very well of being a fire barrier. So we actually called some of the companies that manufacture this type of substance, the shikui, in Japan, and partnered with one of them to start testing and altering the application of it so it could protect our timber buildings. It turned out it's working very well for us. We did our testing already in laboratories. And then the other beautiful feature of this substance is it's antifungal. So we don't end up having mold issues either, which it is susceptible to some of the wall boards if they get damp. And so we can also take that substance now and spray it on the panels in our factory. And so all of our pieces now come fire protected to the site. So a lot of officials are quite worried about fire propagation while buildings are under construction and not really being supervised. And right now, all of our pieces come fire protected from the start. And so we really kind of started changing the formula of how people were looking at timber buildings being erected.
Yeah. That product sounds absolutely amazing.
And by the way, if it chips off or you have to get rid of it, you can just mix it in your garden.
Oh, really?
Yeah.
Oh, that's the best part as well. You also spoke about looking at the origination of the fire and how you can optimize and reduce the risk in that approach as well.
Yeah, so we looked at every piece of the formula, and there's kind of 5 different areas that we can talk about. But obviously, the best way to not have a fire is to stop it at its source. So fires really, about a third of the fires in most cities occur from kitchens or electric fires. So we went after, the first step we looked at was kitchens, what's going on with kitchens, and we removed natural gas. Now, we had a second reason to remove natural gas, and that was going to be to get rid of the greenhouse gas emissions. That's on that path as well. But when we removed it, we went to electric cooking. But when we started to interview the fire officials, they said it's not good enough to do electric cooking. We want to get rid of the heat source off the stovetop itself, which would be like a heat coil. And they said that a lot of people who have actually loose-fitting clothing, this is one of the fire sources, that some of the oils get onto the clothing, they get to the hot surface because they're cooking and their arm goes across, and that's some of the propagation of fire. Or maybe they pick up a towel from the counter to grab a pan or something. So we said, okay, let's go to induction cooking. And they said, well, that would be a game changer. So we got rid of natural gas, but we also went to induction cooking, which has a cool surface. So that was one step to get rid of it. And they said, well, if you do that, we think you could get rid of about 17% of our fire origination. And so then the second step was now we have a lot of electricity running around in the building. And we said, how can we go after that? So we've been looking at a technology that has digital electricity. And so this has been heavily tested. It's in many projects, probably about a couple of hundred actually, but never in a universal scale like going through an entire building, always used for specialty installations. So what this digital electricity does is if it shorts, it has a signal just like a data cable, and it says there's something wrong at the other end of this cable, I'm turning myself off. It turns itself off faster, 30 times faster than any other electric circuit that we have in the marketplace today. And so in this way, we now stop the propagation of electrical fires by the circuit being automatically turning itself off whenever it senses something like that. Our aspiration right now is actually to go all the way to the appliance and understand when you are toasting a piece of bread, how much energy that toaster normally uses. So with our digital electricity, we all can measure exactly the amount of energy that toaster needs at any one moment. So if one day it starts to demand more energy, we can turn that toaster off saying there's something wrong with this toaster. So the device, even if it fails, not just our wiring, can now be identified. So maybe you went and you're reading a book and you put some toast in the toaster, you're going to get an alarm or maybe a message to your phone that's saying, we think there's something wrong with your toaster, we turned it off. And so wouldn't that be a great way to, before you burn the toast too badly, right?
Yeah. And also from a pricing point of view, you were saying how you might be able to get a message and, with all the data of a real lifetime, if you turn the air conditioner on, you can work out how much it's going to cost based on the price of electricity in that one moment.
Yeah, so I think one of the worst experiences of all of ours is we get a utility bill at the end of the month and you see how you behaved, And, if you used a lot of power or gas or whatever it is that you're using, you only find out about it after you've done it. There's really no recourse, right, except to just tell everybody in the house that, hey, can't do this next month. That's too much we're spending. So really we kind of flipped that on its head and said, well, if we're controlling the energy and the thermal loads from the street and we have this very efficient home, how do we let people start to predict or take control of that? And so what we're doing is we're building an app for your phone that actually lets you say, I only want to spend $100 this month, or an average of $100 a month across the year. And it sets up a program for you, a regime, and tells you, well, you're going to have to wash all your dishwasher can only run between 2 a.m. and 5 a.m., or we're going to tell the dishwasher when it can run, when people aren't using power. And this is what the weather is, so we're going to actually, cool your apartment because the weather's going to be very warm the next day, and we should open all the windows and collect some of that. And you can start rearranging how people's bills are created. And then if you don't like it one day, you can change it, and it just tells you that's going to cost you a couple bucks if you really want to do that. But I think that empowers. I think the whole idea of the data that we talked about coming from Google, that engine, actually empowering people to make decisions in real time is kind of the magic of it, right? It's very simple at the end. You dial the price, but all the technology behind that for you to dial in that price that you want to pay, I think is where this data really comes to life.
Yeah. We've been speaking a lot about ways to add value to our buildings, and can we simultaneously make them more affordable? Can you talk about how we can achieve affordability at the same time?
Yeah, so we think the whole concept of certainty for the developer or landowner is a big way to drive down the cost for the building. So if a developer knows that they can get this building delivered and built in a certain time frame that's very exact, and doesn't have all these site problems where the project timeline can get away from them, and if they know the materials are all available because they're all coming out of a factory, so that's very predictable, and if we can price all those materials exactly the way that the factory can order them, we now create this whole environment of certainty. When you create that, the owner now has a much better financial picture of what he can deliver, and it enables him now to take on things like a higher percentage of affordable housing. Obviously, there's incentive programs in all cities around the world to promote that, but I think now the formula becomes a lot more certain, and so people will be willing to take a little bit more, step into it a little bit more, and take some of that responsibility on.
So what do you see as the future of timber structures?
So that's a big question for someone who's just been dreaming to get to where I am today.
Yeah.
I think the future, though, would really be that people just think of it as a normal material to use that has a set of attributes that are very advantageous. We haven't really talked about the whole concept of biophilic design, which really says that people feel well in these spaces. And I think that side of wellness, if we can make the end consumer understand a little bit what's happening there. I mean, they know it, they walk into a wood building and they know they feel good, but to actually understand that that's actually improving their health will be the next step. And I think when we get all those attributes out in front of the public, I think we'll see demand go up. So I look back at the whole LEED, the green building standards that created the LEED certifications. BREEAM is a similar one, and there's others around the world. At the beginning, everyone says, wow, this just costs more money to build one of these buildings because you have all this rigor of design and documentation to get to the correct building materials and assemblies. But at the end, those buildings that were built that way became of higher value. And you can look now and see that a lot of those real estate buildings sell and get bought at higher prices than before. So that value that they put in at the beginning, actually there was return at the end. It took years to prove that. And I think timber buildings will go down the exact same path. Today they just seem like a little more expensive and really beautiful. But when they start to sell and we see that people actually rent them at a higher price, or they sell to another portfolio at a higher price, people understand this investment is really worthwhile for their economically as well.
Yeah, we're seeing that in Australia. The figure of 5% is quoted a lot. So even if it's a cost competitive or even costs a bit more, the payback time is relatively quick if you look over a long enough time frame.
Yeah, I think, and we're going to see more and more of that. And when that starts to become an occurrence that everybody experiences around the world, I think you're going to see a big step into doing these timber buildings. Until then, we're probably going to have to, cities and jurisdictions are going to have to find ways to incent people to try to bridge that gap or coax that to happen. But that's exactly the way LEED buildings went. At the beginning, all the cities had to kind of lean in, and sometimes they gave them some tax incentives, or sometimes the utilities gave them a break on the connection fees, or they would review their plans before anybody else's plans. I mean, those are the types of incentives I think we need to see in timber buildings.
Thanks so much for coming on the podcast, Karim. Would you like anyone listening right now, where should they go to find out more about yourself and the work you're doing at Sidewalk Labs?
Oh, yeah. The work that's been published is the Toronto Tomorrow documents. You can find those on Sidewalk Labs website, or you can just type in, I think, Toronto Tomorrow, and you will get to it. There's quite a bit of reading there, about 1,500 pages. So after you finish, you can send me a note saying I read the whole thing, and I will send you a prize.
Yeah, oh, fantastic. If you got a question about wood, I recommend you check out the Wood Solutions website. It's the world's biggest website on wood, and on it you'll find the technical design guides. So right now there's 48 of them, with that number growing all the time, where we get Australia's leading experts really going deep and detailed in a range of different topics. So if you've got a question, or if you want to just upskill yourself in timber design, then go and check it out.